that whenever you are having a feedback amplifier, we'll be finding out one more output impedance R naught F dash, which is the combination of RL. So R naught F dash is always going to be R naught F parallel to RL. Substitute for R naught F, you know the expression. So take LCM, divide the numerator and denominator by constant terms, and you bring it to a standard form. R naught F dash equal to R naught dash into 1 plus beta A capital A small I divided by 1 plus beta A into capital I, where R naught dash is this term and AI is going to be in terms of A small I. So this is going to be simplification, as I already say, and the simplification for R naught F dash, you download the PDF, you simplify and check whether you are getting this answer. Any mistakes in the terms or sign, please let me know so that I can correct and upload the correct PDF. So this is what we have proved in current shunt feedback amplifier. The input impedance is decreasing, the output impedance is increasing. So that is the characteristics of the amplifier, and circuit wise we have drawn the current shunt feedback input side, output side, and we have separately proved what will happen to input impedance and what will happen to output impedance of the amplifier. See, again, these things will not be separately asked in any question, but they may ask you to explain how input impedance of a current shunt feedback amplifier is decreasing. So in that case, you have to draw the circuit and you have to prove circuit wise that when a current shunt feedback amplifier, the input impedance RIF is going to be RI divided by 1 plus beta into AI. So from this, we can prove that the input resistance after feedback is going to be reduced. So like that, you have to prove. So for that, you should clearly know the circuit diagram at the input side, circuit diagram at the output side. And main thing what you should know is you should know how to apply KVL and KCL as situation demands. If you are not clear on application of KCL and KVL, it is going to be very difficult. Please understand, whatever we studied in feedback amplifier, we didn't study any new concept. What we studied is draw the circuit diagram and we are just applying KVL, KCL, rearranging the terms, and we are getting the relevant expressions what we require. Correct? So we are not doing anything related to feedback. It is just mathematics, KVL and KCL. So if you want to be understanding these feedback amplifiers thoroughly, please brush up your KVL and KCL understanding, and you should be able to apply KVL and KCL at ease for any circuit given. So please practice problems. Please practice problems which will help you to write KVL and KCL equations easily for any given circuit. Okay.